Welcome to Dr. Pat TV. We're looking at linear functions. We'll be playing with how to make the equations of the linear situations that we have. All right, so now before we actually get into the equation, I kind of want to talk about some of the main features of lines. How do we tell them apart? Because how we tell them apart is important for what the formula stands for. And so I got a little fun here. I got some twins here, and sometimes twins are identical and some are fraternal, and so some are easier to tell apart than others. And so we just want to kind of get that frame of mind when we look at lines and where did that equation came up with. What's so important about it? Why is it the way it is? Okay, so how do we tell lines apart? What makes them unique? Well, I've got two lines right here, and I think everybody would agree that those are not the same line. But they do have something in common. They have the same point, but they have different slopes. So they have something in common, but then there's something different about them. So that's why we know they're two different lines. Okay, so we've got different slopes here. What makes these two lines different? They have the same slope, but yet they're clearly not the same line. So what's making these two lines unique? And that would be their different starting points. So they have a different y value, and once you start at different points and then have the same slope, you're always going to have two different lines. Just like railroad tracks, they're never going to cross that way. And so the key point that I want to bring your attention to is what makes lines unique. What's the information that we could use to identify lines? It's their slope and their starting points. So those are two pieces of information that we play with. And so if we're talking about slope, another word for slope is rate of change. And hopefully you recall by now that slope using the letter M. And so we've got change of the output over the change of input. Change of y's over change of x's, and we like to use that little delta symbol there. Basically means change for your math geeks. Okay, so delta right there, that's delta y over delta x, change, rates of change. That's where we're getting this from. Okay, so now for equations of the lines, we've noticed that what makes lines distinct is their slope and their starting point. And so that's why you have the equation y equals mx plus b, is because it incorporates the two key parts about what makes lines unique, and that's their slope and their starting points. Now, I just want to bring your attention, we can do mx plus b. You could also do b plus mx. It's basically the same relationship. It's just got a different look to it. So some people like to have that starting value at the beginning and then talking about the rate of change with the x there. So just be ready for that in some of your econ books or other books that you may have. Okay, I'm going back to an example I've done in a previous video, and that's my Star Uli's Cafe. We have the revenue graph and then we have the total cost graph. And so in this case, what we want to do is come up with a formula for total cost. So now whenever you got a graph and you got a line, because I've got a straight line right here, and you want to make the equation of that line, just pick 2 points. So my first point that I'm picking is right here at 0, 500, and the second point that I'm picking is this nice point here at 10, 1000. When you're working with the graph, pick the nicest points that you can find. Make it easy on yourself. So where a point is right there on where tick marks cross, those are advantage points. Okay, and so I've got 2 points. Now what I want to do is I got to calculate the slope, and so that's my change of output, in this case my change in total cost over my change in time. So I just took the y values on top and then the x values, or the t values in this case, on bottom, and I do that calculation. I get 50. So basically we've got a slope of 50. So this line is $50 per hour. And then we got a b value of 500. This y-intercept right here, it's a nice point. It's a great point to use. So I've got my b value. So in this example, I've got my slope and I've got my b value. I'm just ready to plug those into my formula. And where you saw y before, I'm using TC for our applications. Instead of y, it's so generic, it's so math, it's abstract. Let's get business, let's get to our examples. And so TC for total cost. And then I've got 500 plus 50t, and I'm using the small t for time. So instead of using x, we're using t. And I've reversed it around as well. I got 500 plus 50t. You could write 50t plus 500. Doesn't matter, but I just want to show you the flexibility because I know some econ professors, they like to use 50 or 500 plus 50t. They like to start off with that fixed cost or that fixed value, then add on how the variable cost impacts things. Okay, so another example, another equation we have for slope is the points, or for equations of lines, is the point slope formula. And so this is just a variation of slope, and it'll come out to be the same thing as y equals mx plus b in a moment. Okay, so when we're finding the equation of a line through 2 points, we're going to use the point slope form. And what you first have to do is find these steps. You got to first find the slope, and then you plug the slope and a point into this formula. Okay, so that's what we got to do. It's basically a two-step process, and then with some algebra to clean things up. All right, so I got to calculate my slope. I take these 2 points. I do the y values on top, the differences in the y values, and then divided by the differences in the x values. When I'm doing that, just make sure to note that that's a minus -4. That makes it a plus, so that's really a 16 on top. 16 divided by 2 gives me my 8. Once I've got my slope, I pick either of the points. It does not matter which point you pick. I'm using the 3, 12. That way I didn't have the negative thing. And so I plug in 12 for that y1 there. And then I plug the 3 in for that x1 there. It's basically the x value of the first data point, y value of the first data point, and it doesn't matter who you call first or second data point. Then I plug those numbers in, and so now I'm ready to clean up. I'll multiply this 8 through, and then I'll bring the 12 over by adding 12, and now I've got basically my y equals mx plus b form. But I started with the point slope formula because I've got a slope and a data point. I didn't have the y-intercept. That's why I went this direction. Okay, so there's an introduction to how to make the equations of the lines. I've got 2 different approaches to doing it. Just depends on what information you start with. If you've got the y-intercept, then go ahead and use that slope-intercept form. If you've got a point and a slope, then use the second form. Either way, does not matter to us because in the end, we're going to have the same formula. Thanks. I hope this helped. Have a good day.